The human skeleton gives the body its shape and provides physical support for the systems contained within. It also forms part of the musculoskeletal system that enables us to move. The structure of bone is optimized so that it is strong but relatively lightweight. The interior of bone is composed of bone marrow. It is surrounded by two major types of bone tissue: cortical bone, or the hard outer shell of bone, and trabecular bone, the spongy-looking center. The amount of each type of tissue in bone is dependent on the function of that bone. The basic unit of cortical or compact bone is the osteon. It is composed of successive concentric lamellae. This structure contributes to bone strength by resisting bending. Cells called osteocytes are distributed within the concentric lamellae. Osteocytes form a complex network that is thought to be important in maintaining the viability and structural integrity of bone. At the center of the osteon is the Haversian canal. These canals contain blood vessels and nerves. The blood vessels within bone facilitate the exchange between osteocytes and the blood. Trabecular bone is present in the interior of some bones and resists compression. Osteocytes are also contained within its structure and again play an important role in sensing local changes in strain. Trabeculae are covered in a layer of flattened lining cells that are thought to be involved in the dynamic process by which bone is formed and broken down. Bone marrow is found within the interior of bones. The surrounding trabeculae and vascular network provide structural support, nutrition, and a waste removal system for the heterogeneous group of cells found within this space. Bone marrow is a site for hematopoiesis, the process by which the cellular components of blood are formed. Bone is a dynamic tissue that is continually being built, broken down, and rebuilt in a process called bone remodeling. Bone tissue is broken down and resorbed by multinucleated cells known as osteoclasts. These cells are derived from monocytes, which originate within bone marrow. Osteoclasts play an important role in liberating minerals and other molecules stored within the bone matrix. Bone tissue serves as a repository for vital minerals, including calcium phosphate and various biologically active molecules, such as growth factors. The release of calcium from the bone can play a role in maintaining its homeostasis within the body. The cells responsible for building new bone tissue are known as osteoblasts. Osteoblasts are thought to be derived from cells found to be associated with blood vessels. Once active, they start to produce the organic component of bone, osteoid, which is predominantly made of collagen. Minerals start to crystallize around the collagen scaffold to form hydroxyapatite, the major inorganic constituent of bone, which contains calcium phosphate. Bone mineral density, or BMD, can be used to estimate the strength of bone and to assess the risk of fracture. As osteoblasts form new bone tissue, many become embedded within the matrix and differentiate into osteocytes. The structure, composition, and cellular processes that occur within bone allow it to simultaneously serve as a calcium reservoir, while providing structural support for the vital organs and for locomotion.